welcome. If you are new to this channel, hi, I'm Anchita Divagran. Welcome to CodeGenix. In this channel, we discuss about all the things related to technologies and programming. Today, we are going to discuss a Leetcode problem called longest substring without repeating characters. So without any further ado, let's just dive right into this video. Our problem statement is, given a string, find the length of the longest substring without repeating characters. Let's understand the problem statement with an example. Suppose our string is the one shown in the screen. We can have many substrings like A, B, C, ABC, BCA, etc. But according to our problem statement, our first condition is that the substring should be long. So, we will not consider the substring like A, B, C, ABC, etc. The next condition is that we cannot use repeated characters. So, we will avoid substrings like BCB, etc. So, let's discuss two solutions. One is the brute force one and the other is the efficient one. Brute force solution. The brute force solution will be by taking out all possible substrings from the given string and then check if there is a repeated element in the substring, then compare and return the largest substring length. This isn't a good idea as there is a linear increase. So, the time complexity of our brute force solution is order of n cube. So, what can we do for an efficient solution? We can use sliding window method. Here, we will initialize two index left and right to get the characters. We will also create an empty dictionary which will store the seen characters in the string. By doing so, what happens is that we will save the lookup time for the repeated characters. For instance, the left and right index is initialized to 0. It checks if the character that the right points to is there in the dictionary or not. If it's not there, we will update the value and index in the dictionary. Then we will change the right pointer to the next character and increment our result. This goes on till we encounter a repeated character. Then we will increment our left pointer and the process goes on. So let's start coding in Leetcode. We will first initialize three variables, right, left and result to 0. And also we will initialize a dictionary named scene. Here, scene dictionary is used for storing the characters that are visited once so that we can identify when a character repeats. Next, we need to loop through the string. For that, we will define a while loop with condition both left and right index terminates if it exceeds the length of the string. We then check if the character is there in the scene dictionary or not. If not, then we will add the element as key and right index as the value in the scene dictionary. Or else, we will move our left index if scene element is there in our window. Then we will update our result. Then we will also update the right index value in the scene dictionary and also increment the right index. After that, we will return the result. We can get a clear understanding after discussing the solution with an example using the following string. In first iteration, we will first initialize the left, right and result as 0. We then create an empty dictionary, scene. Then in the while loop, we will check if the right and left index is less than the size of our string. Here it's 0 less than 8 and 0 less than 8. Since it is, we get into the if condition where we check S of 0 means A is there in our scene dictionary or not. Since it is not, we will append that element to the dictionary as key and the index of that element as value. Then we will calculate the result as max of 0, 0 minus 0 plus 1, which is 1, and update our right index to 1. In second iteration, we will have the result as 1, right index as 1, and left index as 0. We then go to the loop and check if the right and left index are less than our string length. Since it is, we will check if S of 1 is there in the scene dictionary, that is, B is there in our scene dictionary or not. Since it is not there, we will update B as the key and index 1 as the value of the dictionary. Then we will calculate the result, that is max of 1, 1 minus 0 plus 1, which is 2, and update our right index to 2. In third iteration, we will have result as 2, right index as 2, and left index as 0. We first get into the loop and check if the right index and left index is less than the size of our string. Since it is, we then check if S of 2 is there in the scene dictionary or not. Here, D is not there in the scene dictionary. So we will append D as key and index 2 as value of the scene dictionary. Then calculate result as max of 2, 2 minus 0 plus 1, which is 3, and update our right index to 3. In our fourth iteration, we have result as 3, right index as 3, and left index as 0. We get into the loop and check if right and left index are less than the size of our string. We then check if S of 3 is there in the dictionary or not. Since C is not there in the dictionary, we will append C as the key and 3 as the value of that scene dictionary. Then calculate result as max of 3, 3 minus 0 plus 1, which is 4, and update the right index to 4. In the fifth iteration, we have the result as 4, right index as 4, and left index as 0. We then get into the loop and check if the right and left index are less than the size of our string. Since it is, we then check if S of 4 is there in the scene dictionary. Since B is there in the scene dictionary at the index 1, we update our left index to 2, then calculate the result as max of 4, 4 minus 2 plus 1 as 4, and then update the right index to 5. In sixth iteration, we have result as 4, right index as 5, and left index as 2. We then get into the loop and check if right and left index are less than the size of our string. Since it is, we then check if S of 5 is there in the scene dictionary or not. Since B is there in the dictionary with value 1, we update our left index to 2. Then calculate the result as max of 4, 4 minus 2 plus 1, which is 4, and update our right index to 6. In seventh iteration, we have result as 4, right index as 6, and left index as 2. We then get into the loop and check if right and left index are less than the size of our string. Since it is, then we will check if S of 6 is there in the scene dictionary or not. Since A is there in the scene dictionary with the value 0, we update our left index to 1. Then calculate the result, max of 4, 4 minus 1 plus 1 as 4, and update our right index to 7. In 8th iteration, we have result as 4, right index as 7, and left index as 1. We then get into the loop and check if left and right index are less than the size of our string. Since it is, we then check if S of 7 is there in the dictionary or not. Since A is available in our dictionary with value 0, we update our left index to 1. Then calculate the result as max of 4, 4 minus 1 plus 1 as 4, and update the right index to 8. In 9th iteration, we have our result 4, right index as 8, and left index as 1. We check the loop if right and left index are less than the size of our string or not. Here it's 8 less than 8 and 1 less than 8. The condition doesn't satisfy. So we print our result, that is 4. So we have said that this is one of the efficient way of solving this problem. So the complexity of the solution is order of n because we have one while loop which runs till the end of all the characters in the string. That is it. Hope you all understood the solution. Any query regarding today's topic, comment down below. Thank you for watching. Please make sure to like, share and subscribe. And also to press the bell icon to get the notification of my new videos. Until then, take care. Bye-bye.